Hello, I am Professor Abhishek Das of MIT School of Engineering, and today I will teach you the introduction to the logic gates. Right. So to start with the logic gates, we can say that, so what is a logic gate all about? So a logic gate is, can call it as a building block of a digital circuit. Okay. So that has two inputs and one output. Now, the relationship between the input and the output is based on a certain logic. Okay. So now these gates, as you can see over here, so these gates are implemented using some electronic switches like transistors, diodes. But in practice, the basic logic gates are built using the CMOS technology. It is the FETs and the MOSFET metal oxide semiconductor FETs. Okay. Now, let's start with the first one, that is the AND gate. So AND gate IC number is IC7408. Okay, so basically there are AND gate, OR gate, NOT gate, NAND, NOR, XOR, and XNOR gates are available. Okay, and out of this, so to start with the AND gate, that is IC7408. Okay, so before starting with the AND gate, let me explain that what are the different components required to implement a particular gate. Okay, so the first component that is actually required to implement a particular IC is breadboard. So breadboard is actually very much important required, where you will actually have to place the IC in the breadboard to implement that particular logic. Next come so the wires by which you will have to connect, and obviously the logic gate you need. So it can be actually more than one logic gate, and the light emitting diodes, that is the LEDs, in which in some cases it will glow and in some cases it will not glow, right? Now, out of this AND gate, OR gate, NOT gate, NAND gate, NOR, and XNOR, we can say that AND, OR, NOT, so these three gates are the basic gates. Okay, so AND, OR, NOT are the basic gates, as with the help of these three gates, we can actually perform the concept of the other gates as well. So, which means that for NAND gate, we can like implement the AND gate and NOT gate to implement NAND gate. Okay. Similarly, for NOR gate also, to implement NOR gate, we can implement OR gate and NOT gate. Combination of OR and NOT will give us the output of NOR gate. Okay. And again for XOR gate, if you implement XOR gate and NOT gate, you will get XNOR gate. Okay. So this is all like it works like this. Now I will show you the different components that are required actually for the implementation of our any ICs, right? So the first is the breadboard. So this is how a breadboard looks like, right? And this is how we'll have to place the IC in the breadboard. So this is the middle portion is called the mid rib. Okay, so you'll have to place the ICs. The first, the left side of the IC must be on the left hand side of the breadboard on the one side, and the other side of the IC must be placed on the like on the other side of the mid rib of the breadboard. Okay, now after the breadboard, you need to have some wires and for the connection purpose, and obviously the logic gates you need to have, and finally the light emitting diodes or the LEDs. Okay, so now let us start with the first gate, that is the AND gate. Okay, so what is an AND gate? So AND gate is, we can say it is actually a digital logic gate with n inputs. So in case of over here, as you can see, we have two inputs, but generally we can say that inputs can be of n inputs and one output. Okay, so which performs the logical conjunction based on the combination of its inputs. Now, the output of this gate is true. Okay, that means it returns 1 when all the inputs are true. Okay, so from the truth table, you can see that when all the inputs are 1 or all the inputs are true, then only you will get the output as true or as 1. Else, right? So if any one of the input is false, okay, if any one of the input is false, you will get the output as false or you can say it, you can call it as 0. Okay. Now this is the symbol of the AND gate, and this is the truth table of the AND gate, where we are using the 2 inputs and 1 output. So A and B are the 2 inputs and the output is C. Okay. So now the AND gate is actually represented with the dot operator, where C is equals to A is the output and B is the output, and C equals to A dot B. Okay. Or in some other books, you can see that C equals to AB also, it is denoted like that also. So over here we are actually doing multiplication, right? So 0 into 0. So if we are calculating the product of the 2 binary values, so these are all binary values, right? So 0, 1, 1, 0, this kind of things. So if you are calculating the product of 0 into dot 0, so you are getting 0. So 0 dot 1, the product you will get 0. So 1 dot 0, you will get 0, and 1 dot 1, you will get 1, right? So this is how the truth table of the AND gate works. Now let us come to the circuit diagram of the AND gate. So this is how the circuit diagram looks like. That let's say we have 2 switches A and B. So for that, if any of the switch, so from the circuit you can see that if let us consider this as the bulb. Okay, so if any of the switch, either A or B, turns out to be like false, we won't get the output, or the bulb will not glow. Okay, so lamp will only glow when both the inputs or both the switches, that is A and B, if both of them are true, like if the both of them are on, that is 1, then only the bulb will glow, right? And if any one of them are like false, so if A is false and B is 1, like if A is 0 and B is 1, then the connection will not be complete and the lamp will not glow. And the vice versa is also true, right? Now let us come to the pin diagram. Okay, so now from the pinout diagram of the IC7408, that is the AND gate, you can see that we are having the 14 pin IC. Okay, so it starts from 1 over here, so 1 to 7, and then again in the reverse order 8 to 14. Okay, so over here we are having 14 pin IC, 7 and 7. So each side we are having 7 pins. Okay, so part 1 input. Okay, so this is the first input, this is the second input, and for these 2 input we are having the output over here in the pin number 3. Similarly, for part the pin number 4 is the first input, pin number 5 is the second input, and pin number 6 is the output of these 2 inputs, 4 and 5. Now GND means ground. Okay, so which actually means we'll have to connect this pin with 0 volt. Okay, and VCC means we'll have to connect this you will have to connect this with the power supply. So it will be 1, this will be 0. Okay, and again for this side, that is pin number 13, 12 and 13 will be the input, and pin number 11 will be the output. Again for pin number 10 and 9 will be the input, and pin number 8 will be the output. So this is how the AND gate works. So inside one IC, you are having one input. So two inputs, you are having one output. So one output, then two output, second output you are having over here, then third output you are having over here, and fourth output you are having over here. So in a single AND gate IC, we can actually implement the concept of AND gate with any of the four combination of outputs. Okay. Now let us come to, so this is the diagram, or not the diagram, this is actually a photo of the AND gate. So as you can see over here, that is IC7408N. So this is how the AND gate looks like. Okay. So this is all about the AND gate. So next, on the next class, I will show you, or I will explain the concept of OR gate. Okay. So that's it for today.